Bismillahirrahmanirrahim. In today's lecture, we are solving problem 3.55 from the book Thermodynamics and Engineering Approach by CENGEL. So, the statement of the the statement of the problem is a piston cylinder device contains 0.1 cubic meter of liquid water and 0.9 meter cube of water vapor in equilibrium at 800 kilopascal. Heat is transferred at constant pressure until the temperature reaches 350 degrees centigrade. First I write given data. So initially initially there is liquid water mixture, liquid and vapor mixture. So in which the volume of liquid is 0.1 cubic meter. It means that Vf is the volume of liquid, which is equal to 0.1 cubic meter, and volume of vapor, which is Vg, which is equal to, and this is total volume of liquid and total volume of vapor, which is 0.9 cubic meter. In equilibrium at 800 kilopascal, it means that P1 is equal to 800 kilopascal. Heat is transferred at constant pressure. Pressure is constant. It means that P1 is equal to P2 is equal to P. Pressure is constant until the temperature, until mean that the final temperature is 350 degrees centigrade. Required is, what is the initial temperature of the water? Required, number A, initial temperature mean T1. Number second, determine the total mass of the water. Number B, find total mass. Number C, calculate the final volume, calculate V2. And number D, draw the process on a PV diagram. So first we find T1. As we know that initially the water is mixture of liquid and vapor. It means that it is in wet region. It is, the water is in wet region, so the temperature in the wet region will be saturated temperature. Here this is the PV diagram. So in PV, pressure in kilopascal and volume is in meter cube per kg, specific volume. This is the saturation curve. Initially the water is in wet region, and this region is the combination of liquid and vapor, and in this region we know that pressure is constant, and in this region we know that from this point to this point pressure is called saturation pressure and temperature is called saturation temperature. So from this point, from completely liquid form to completely vapor form, the temperature is constant, and that temperature is called saturation temperature. So we have to find the temperature at this point. This is point 1. So at this point temperature is saturation temperature, and pressure is constant. P1 is equal to P2 is equal to 800 kilopascal. So we will find saturation temperature. So from saturated steam table at pressure is equal to 800 kilopascal. Initial temperature T1, this is solution for A. At pressure is equal to 800 kilopascal. T1 is equal to Ts, which is equal to 170.43 degrees centigrade. And this temperature is given in the table. At T1 800, and at this is saturation temperature. If we check top of the table, this temperature is saturation temperature, and this is pressure. So air pressure is equal to 800 kilopascal, saturation temperature is 170.43 degrees centigrade. Now at point B, solution of B, we have to find total mass. So for total mass, first we find mass of vapor and then mass of liquid. So first we find Vf, specific volume of liquid, and Vg, specific volume of vapor, from this table. So from saturated steam table, at pressure is equal to 800 kilopascal. Specific volume of liquid is equal to, this is 0.00, this is Vf, 0.00115, 0.00115 meter cube per kg, and this is Vg, this is this is this is Vf, this is Vg, this is Vfg. Vg is 0.2403, 0.24043 meter cube per kg. First we find specific volume, specific mass, mass of liquid. As we know that specific volume of liquid is equal to total volume of liquid divided by mass of liquid. मतलब specific is equal to total divided by mass. We have to find mf, so rearrange this equation. Mf is equal to total volume of liquid divided by specific volume. Total volume is given to us as 0.1 cubic meter, and specific volume of liquid is 0.001115, 0.001115, there are 31 meter cube per kg. Meter cube will be cancelled with meter cube, kg and double division will be here. So mass of liquid is equal to 89.686 kilogram. Now we will find mass of, from this formula, mg, mass of vapor, is equal to total volume of vapor divided by specific volume of vapor. Total volume is given to us as 0.9 meter cube in given data, and specific volume is 0.24043, 0.24043 meter cube per kg. Meter cube will be cancelled with meter cube, and mg is equal to 0.9 divided by this is equal to 3.743 kilogram. Now we can find total mass. Mt is equal to mf plus mg. Mf is equal to 89.686 kilogram plus mg is 3.743 kilogram. So total mass is equal to 93.429 kg. 93.429 kilogram. This is total mass. Now in part C we have to find V2. In part C we have to find V2. First we will check whether V2 is in wet region or in superheated region. So as we know that at T1 is equal to 170.43 degree, at P1 is equal to 8, at P1 is equal to, as we know that at P1 is equal to 800 kilopascal. Saturation temperature is 170.43 degrees centigrade. So at P1 is equal to, at P2 is equal to 800 kilopascal. T2 will be equal to, this is Ts is equal to T1. T2 will be equal, T2 is equal to 800 degrees centigrade, 350 degrees centigrade, 350. As saturation temperature is this, so 350 will be superheated temperature. It means that this is PV diagram. From this point to at constant pressure, from this point to this point, Th is equal to 170.43 degrees centigrade. It means that 350 degrees centigrade will be here beyond this point, because up to this point temperature is 170, up to this point temperature is 170.4. It means that T2 is equal to 350 degrees centigrade, and is beyond this point, and this is PV diagram as well. So this is point 1 and this is point 2. So T2 is equal to 350 degrees centigrade is superheated temperature. So point 2 will be in superheated region. As at P2 is equal to 800 kilopascal, T2 is equal to 350 degrees centigrade is superheated temperature. So point 2 will be in superheated region. So for V2 from superheated steam table at pressure P2 is equal to 800 kilopascal and T2 is equal to 350 degrees centigrade. Find V2. So this is specific volume. Check here the this is superheated steam table, superheated vapor table, and this is pressure 800 kilopascal and temperature here is 350. So at 350 degrees centigrade and 800 kilopascal, specific volume, this is the value of specific volume V, this is V specific volume in meter cube per kg, which is equal to 0.35439, 0.35439 meter cube per kg. Now we have to find total volume. So as we know that specific volume is equal to total volume divided by total mass. So this implies that total volume is equal to, rearrange this equation, total mass into specific volume. So total volume is equal to total mass is 93.429 kg, 93.429 kg multiply by specific volume is 0.35439 meter cube per kg. This kg will be cancelled with this kg. So total volume is equal to 93.429 multiplied by this, which is equal to 33.11 cubic meter. And part D, point PV diagram. Already drawn the PV diagram. Again I explaining the PV diagram. This is pressure in kilopascal and this is specific volume in meter cube per kg. This is saturation curve. Pressure is constant, it means that this is constant pressure line. P1 is equal to P2 is equal to 800 kilopascal. Initially the water is mixture of liquid and vapor. It means that initial point is here between saturated liquid line and saturated vapor. Finally the steam is superheated at 350 degrees centigrade. So this is point 2, this is point 1, this is point 2. Constant pressure line is point 1 to 2. Here temperature is saturation temperature T1 is equal to 170.43 degrees centigrade. Here temperature T2 is equal to 350 degrees. So this is the PV diagram for the problem. And for more problems, please like and subscribe my YouTube channel. Thank you.